Hi, I'm Dr. April Ronca, Chief of Research at the Advanced Space Life Research Institute and Adjunct Professor of Obstetrics and Gynecology at Wake Forest School of Medicine. I'm also a co-investigator on NASA's Rodent Research-20 mission that sent female mice on the International Space Station for 60 days to explore how the space environment influences fertility and future generations, opening the door to one of the most fundamental questions imaginable: what happens to reproduction and offspring development in space? My own journey began years ago during my graduate and postdoctoral training when I set out to understand how mothers influence their young before and after birth. That work led to a pioneering opportunity to study pregnancy and development of rats on the NASA Space Shuttle. To our amazement, after spending the second half of their pregnancies in space, the mothers returned to Earth and, right on time, delivered robust litters of healthy offspring. Yet, the spaceflight pups' brains developed a bit differently. Their gravity sensing systems were altered, and their early balance and coordination was impaired. Our first clue that spaceflight can shape life from the very start. Today, NASA's RR-20 mission builds on that legacy, exploring how spaceflight may affect ovarian function, hormone signaling, and even the skeletal support systems for reproduction and growth. For women astronauts, whose numbers have increased dramatically over the past decade, these questions are both scientific and deeply personal. And when you think about it, from a broader perspective, if humanity truly aims to become a multiplanetary species, we need to know whether we can reproduce successfully beyond Earth. As we prepare for longer missions to the Moon and to Mars, understanding how space influences every stage of life, from conception to gestation to birth and beyond, becomes essential. A particularly compelling and interesting question is whether the biological imprint of life in space could be passed down to future generations, perhaps through epigenetic transmission, the chemical marks on DNA that act like molecular fingerprints, shaping how genes are expressed and potentially carried forward. It reminds us that when we study how life begins in space, we're really studying the future of humanity.